Hi everyone. I hope you guys are having an awesome start to your day. Um, so for today, we only had a 20-minute class, so we didn't get through a whole lot. Um, but I did review um, I was able to review the explosion project. Oh, sorry about that. That was very loud. The explosion project that we did on Friday. So what I'm going to do is I'm going to present my screen so you guys can kind of follow along with what I'm talking about, and we'll go from there. Okay? So hopefully you were able to get the three different trials of, or multiple trials of the mass, excuse me, the mass of the red cart, mass of the blue cart, and then the post-explosion speeds. Now, when you're analyzing the momentum, okay, so when we look at our momentum equation, and with this, oh man, piece of paper. My bad. There we go. So when looking at momentum, our equation is the initial volume. Now, in an explosion, what happens is our masses are combined, and then the velocity final for mass 1 plus the velocity final of mass 2. Okay, so that's our equation. Now, our initial velocity before an explosion is 0, right? So 0 is equal to the final velocity of the mass of object 1 and the final velocity of mass object 2. And since it's equal to 0, these two have to be opposites. Okay, they have to be opposites, which makes it pretty convenient to solve these type of problems. Okay, so referring back to the assignment, what is the initial before the explosion? 0. After, or before, for the blue cart, 0. Okay. Now, considering doing your calculation, kilograms times meter per second. Okay, so hopefully what you see is the post-explosion of the red cart is always going to be the same as the blue cart. They're always the exact same. Okay. So 5, how do the direction of these two post-explosion vectors compare? Well, the vectors are the exact same, however, they're opposite directions. So they're equal but opposite directions. And number 6 says, what is the vector sum? Well, if they're equal but opposite, the sum is going to be 0. They cancel each other out. Okay. Use your answer from 3 in question 6 to explain how one can say that momentum is conserved in an explosion. Okay, so momentum is conserved because the final velocity of mass 1 is going to be the opposite of the final velocity of mass 2. So the explosion is conserved. It started off with initial momentum of 0, and the final momentum was indeed 0. Okay. Number 8 says pick 3 different trials and have a different mass ratio for each trial. Okay. Basically, from this, what you should have found out was they're opposite reciprocals. Okay, so yeah, they're opposite reciprocal. Okay, and analyze the date, state the rule. Okay, perfect. So that is that. Now, what I'm going to also do is we watched a little video today. It's about a railgun that the Navy uses. It's pretty interesting in how it uses like electromagnetic energy to shoot a bullet going over 6 Mach, which is 4,500 miles per hour. It's pretty interesting. So I will post that video just in case you want to check that out. But that is all we did today. So I hope you guys have a good day, and we will see you tomorrow.